Good day, I'm Dr. T and welcome to my office. So today I'd like to talk about how we communicate scientific research. So if I'm a scientist and I'm going into a lab, I'm doing some experimentation, I discover stuff, and if I don't tell anyone, that was a complete waste of everyone's time and resources. So instead, I need to communicate to the greater scientific community what I've learned so that they can build off of my discoveries and we can make cool stuff in the future. So how am I going to do this? Well, the way that we've pretty much settled around, although there are some changes coming in this approach, is known as the peer-reviewed journal article. So in this particular article, what I'm going to do is I'll write up an article, and it's fairly stylized. So it starts off with a brief summary, what we call an abstract. Might as well be the TLDR. And then it jumps into a few paragraphs of an introduction. This is to bring the general scientists up to speed on the specific topic in hand that they can actually read the rest of the paper. This is assumed that this is someone who has got, say, a bachelor's or so in whatever broad field that this happens to be. This is needed because there's a lot of detail and there's far more scientific knowledge than any one person can ever hope to begin to understand. So a researcher studying a specific topic is going to have a far more intimate discussion and knowledge of this topic than what general people who are even scientists in the general field of that topic would understand. And so this is to allow the general scientist in that field to understand enough to understand the meaning of the experiment. Then there's a section called methods or materials and methods, which is basically how the experiment was done. This would allow for replication of the experiment if somebody wanted to try that experiment out for themselves or modify the experiment and do something else. Alternatively, it would also allow the person to go through like, wait a minute, you didn't do this right. Why didn't you do this or that? And thus raise questions if those were there. The next couple of sections, results discussion, which sometimes are separate, sometimes are together, which is basically the results, what I found in my experiment, discussion, what does that mean? Sometimes there's a conclusion, of course, acknowledgments, and a ton of references. So I write this up. These are typically not that long because no one wants to read a bunch of stuff. So you want to be brief. This does lead into some really dense writing. And they are in third-person passive, which is a really bizarre way of writing, which definitely, when introducing folks who are not used to that style, becomes a little bit of like, wait, what? This is what English professors say not to do. Okay, so I've written this thing up, and now I'm going to send it off to a journal. And so each journal is going to have, a slew of editors. And they're going to read over it and they're like, okay, does this fit the theme of my journal? Is this something that's interesting? If this is just some boring paper that I don't care about and I'm a prestigious journal, I'm just going to send it back like, no. But if this looks interesting, then the journal editor is going to then send it off to usually about 3 other scientists who are doing very similar research. These are called peer reviewers. And typically, I would have actually suggested some individuals in the process. These will remain anonymous. I don't get to know who peer-reviewed my paper because this allows them to be critical of my work. And what they're going to do is read over it. And the reason that these folks are doing this is because, not everyone knows the in and outs of a very specific topic. I could be making some really quirky conclusions or errors that someone who is intimately familiar with the general topic that I'm covering would know, but someone who is not intimately familiar with that topic that I'm doing the experiment on would not necessarily be aware of. And so these folks can point this out and catch it if I've made some, shall we say, understandable but definitely problematic conclusions. They then give a report. They type up a short paper to the editor that's basically publish as is. That never happens. Publish a few minor edits. Publish with some really major edits, or just throw it out as garbage. After that, after I make the edits that they suggest, assuming they didn't say throw it out, then it gets published in a scientific journal. And people can read it. Yay! Usually they're stuck behind paywalls, but things are being done to resolve that. It's a lot better now than it was 20 years ago. A lot better. So, yeah, I've got that journal article. It's out and about. Now, this is what we call primary research. But primary research is usually answering very, very specific questions. Ones that, maybe can't be generalized, or sometimes my conclusion to a very specific question might be somewhat conflicting with someone else's conclusion to a very similar specific question. And at this point, quite often, after a bunch of primary research papers have been done on a topic, someone will decide to probably have someone under them do a bunch of work by going through, reading a bunch of primary literature, and then summarizing it. Basically, a paper review. And this is called a review article. The review article will summarize what's been done in, say, the last 10, 15 years on a topic, and we're all said and good. However, the folks doing those review articles, there's a couple of issues that can come in. If they have an agenda, then they could be cherry-picking articles. If they just, a little bit sloppy, they could come to conclusions that maybe aren't ideal for those topics. For most areas, it's boring enough that people don't usually have that much of an agenda, and there's not one of those kind of gray areas where it's like, it's unclear what the consensus is. Most of the experiments are kind of going in the same direction. But when you do worry about a topic where people might have an agenda, or where it's not actually that clear, there's a bunch of folks going one way and a bunch of folks going the other way, then we start needing to get into somewhat more advanced styles of review. The next layer up is known as a systematic review, and this gets rid of cherry picking. In this case, the authors of the review have a materials and methods section, and they lay out in that section why they picked what papers they picked. Specifically, they'll set up a criteria. They'll say, hey, papers produced within the last, say, 10 or 15 years that meet these specific criteria. And then every paper that has been produced in those time period that meet those criteria is reviewed in that article. Now, this way, we can debate whether or not those were good criteria. And of course, that will take place. But we know the person wasn't cherry picking, assuming they actually followed their own criteria, which, people usually aren't bold-faced lying in these things. That's a good way to get yourself fired and never hired by anyone else. That's a great approach. But that's actually still problematic when you've got a lot of papers saying one thing and a lot of papers saying the exact opposite, where there's a lot of confusion. To handle this, there is then the meta review. And this is kind of the top tier best review you can get. In a meta review, it starts out exactly the same as the systematic review, except for the results sections of all the papers are pooled together. You take the results from the papers and mathematically combine them together, and you do a statistical analysis over all of the data provided in all of the papers that you're reviewing. By doing this, you can then get a more clear picture of what the understanding is as a whole, or in its totality. Of course, sometimes it comes out that it's still very vague and very unclear, but usually clarity starts coming in from the noise. Generally, the more information you can statistically cram together, the noise tends to cancel itself out, and that's the goal with the meta review. Now, of course, with all things, there are problems. As I mentioned with reviews, cherry picking can definitely be an issue, but hopefully that's not such a big issue, and systematic and meta reviews are there to resolve that. Another issue is a kind of a bizarre form of cherry picking, kind of a reverse cherry picking. This is called publication bias, and this is when you do a study and it's boring. If I find a way not to cure cancer, that's not that interesting. I may not even bother to write the paper. It's like, this isn't worth my effort. No one's going to read this. Or if I do write it, it goes to the journal, and they're like, yeah, we got 20 things to print, 10 slots, yours ain't getting in there. So this becomes actually a serious problem. For pharmaceuticals, where this is really a potential issue, there's new approaches where before you start the experiment, you have to set up a pre-publication where you will publish no matter what the results of your experiment are. And this helps get away from this issue because, once again, there's been quite a few drugs where it's like, hey, 5 people researched it. 1 showed it cured cancer. 4 showed it didn't. Only 1 of them got published. Guess which one? So that does help resolve some of the issues. There is one other issue that we're having This was a little bit harder to address because it takes money. Remember how I talked about the method section on how this would allow individuals to reproduce your work if they so choose desire. This reproduction is an essential part of the scientific method to understand if something really worked or if it was simply a fluke. Because it's entirely possible that some unknown variable outside of your knowledge unintentionally changed the way your results worked. And this happens quite a lot. So if somebody else, completely independent of you, redoes your experiment or does one very close to yours, then that would confirm or dispute your work. However, that costs money, and granting agencies, those who give money out, are more tempted or more desiring to give money out to people doing new things than just redoing something someone's already done. And thus we are led with what's known as a replication crisis. Once again, we are working to fix this, but the solution is to literally throw money at it. Well, not literally throw money at it, but to spend more money, and, well, money's tight. So, yeah. Overall, the system works well. If you are reading scientific papers, I strongly encourage you to do so. Google Scholar is a wonderful resource. If you're new to a topic, I don't recommend starting off with primary research. That's typically really dense. So typically, when I'm getting into a new area, I either read a textbook or Wikipedia. Wikipedia is actually usually pretty good in most categories. It is effectively peer-reviewed. And then jumping into review articles. With Google Scholar, just type in the word review with whatever topic you're doing, and a good chance you'll get the articles you want. No guarantees it won't be behind a paywall, but you got a good chance. And then from that, jump into the peer-reviewed area. Obviously, if it's some kind of controversial issue, yeah, go full meta review. Those really are the gold standard. And in many topics, you got to go with the gold standard. Otherwise, cherry picking becomes an incredibly major issue, or just dumb luck. And if you read 2 or 3 articles, they may not be spot on what truth is. You want to statistically average them together, and that's what the meta review does. So with that said, have a wonderful day, and don't be afraid of scientific literature. It's a little daunting, but not as bad as it seems if you start with a good old review article.